Hey guys, so welcome back. Tonight, this is, this is week 11, module 11 on your modules. And tonight we are going to be starting with kind of the culmination of all the stuff that we've been doing. So, primarily as, even if you're a drafter or a designer or an engineer, the ultimate thing that we're trying to do is this idea that we've got in our head. We're trying to get it out into a medium that is understandable by other people. And traditionally, now this is changing in more recent years. This is turning into models, I think called model-based definition that I'll talk about here pretty soon. And but traditionally, that is done through drawings, engineering drawings. You've probably all seen these engineering drawings before. They can be relatively simple. They can be extremely intricate and difficult to read. But our goal, as this person who is creating this thing, is to make the engineering drawing the easiest that it can possibly be to be understood. All right, we are trying to convey messages here. And we are trying to do that in a way that cannot be misinterpreted and that can be easily done. The majority of the time, the people who are reading these things, because they don't create them, they just don't always look in the intricate spots. We need to make it easy to read, and that's not downplaying them. These people can do stuff that we can't even pretend to start doing with machinery. However, a lot of the times, if you make the drawings too difficult to read, they will misinterpret them because they're busy trying to work out the mechanics of what they're doing. They need to be able to spend their brain power doing their stuff and not trying to figure out what the heck you just slopped down on your page. So, again, essentially, and this is kind of the culmination of what this class is, of what our goal is as designers, as engineers, as drafters, is to get the idea out on paper so that anyone can look at this thing and understand it. So what that boils down to in our case is we're going to be using some of the assignments that we've already done. In this case, we're going to be using the Extrude EXE1, as you see on my screen. I will have this as a download on the module right underneath if you do not remember where it is. However, I would rather you used your own model for this. I would much prefer that. So we're going to start doing that. We're going to start using these to create these engineering drawings to get across the entirety of the understanding of what these are. Now, there are engineering drawing kind of guidances in the book. Let's see, here we go. So we are not really going to be going over a whole lot of the intricacies underneath the templates and stuff, just because the majority of these templates are, they're just broken inside the software, and they take way too much effort to try to fix at this point. I'll show you a couple of little features and little tips and tricks on how to do that. But, so we are going to be doing this one, the EXE1. For your assignment, you will have the machine block in its standard configuration. The regular configuration with the 3 through holes on the bottom and the 3 divots on the top. The spot for that in the book is chapter 16. It starts on 16.1, but it gets into the thick of it around 16.8. So that's where you're going to go for the homework, is going to be 16.8. And then there's a couple of A works that are just relatively simple little render jobs. Those are not too difficult, and they are A work. So at this point, you guys can just wing most of those. The majority of you have a pretty good grade in here. So let's go ahead and start looking at our drawings. Oh, I told you that I'd go over model-based definition really quick. So a drawing is a 2D sheet, obviously. These are meant to be printed out or viewed on screens in a 2D what's the word I'm looking for? Non-interactive medium. Okay, so it's just, we're going to create this thing. It's going to be printed, whether that's saved off in format or actually physically printed. And and then the people look at them and they read the dimensions. So model-based definition is not like that. Model-based definition is where the dimensions are physically, not physically obviously, but are tied to the model itself rather than a drawing. And then the model is what's sent off, and whoever is utilizing this medium for its final product will actually have a 3D PDF. These are drawings that aren't easily printed off in 2D paper form. They can be. You can create 2D papers with this, but it's primarily meant to be viewed on a screen, and it's meant to be rotated around and manipulated so that, so for instance, if this person who is creating this this extrude example here is trying to figure out what's going on back behind this, on a 2D drawing, they may not be able to find the view that properly tells them what is going on back there. In this 3D space, they can just grab it, move it around, and say, oh, okay, that whole thing is flush. So that's what model-based definition does. They can view it on this, they can look at it in this orientation, and it will show up the dimensions that pertain to this particular profile of the part. And so it's less organized, but it's easier for the end user to get the finite example of what you want. So it's got its drawbacks, it's got its benefits, just like pretty much everything else. But in this class for now, we are going to be focusing on the 2D drawings because 99% of the time you're still going to be utilizing those. I've heard that companies like Boeing and McDonnell Douglas, a lot of the aircraft industry, a little bit of the automotive industry is going to this model-based definition stuff. I haven't seen it yet. The majority, actually every single one of our suppliers and manufacturers and customers requires the old school drawings. So that's what we're sticking with for now. Model-based definition is a thing of the future. Maybe 5 years down the road it's going to really light up. But for now, the tech investment that companies would have to do to be able to actually support that would be pretty darn intense. So we're just going to do 2D drawings here. So this is our part that we're going to be working with. In order to start a drawing, we're going to go just like we do with all the other ones. We're going to come up here to our new, and we're going to go to this. Now, if I hit drawing, I'm not 100% sure what I'm going to be getting. So I'm going to go down here, and this is probably a button that none of you have pressed yet. But at the bottom left side of your new SolidWorks document screen is a button that says Advanced. So let's go ahead and hit that. We can see, oh, here's model-based definition. So this is a bunch of model-based definition stuff we can do. We're not going to get into that. Here's a bunch of tutorial stuff. We're going to go to the templates and drawing. We don't have any other sheet formats for drawing, so we're just going to go ahead and double-click on drawing. Now, when this comes up, hopefully it will ask us for paper size. Okay, so paper size, when you're looking at drawings, there's a bunch of different types of paper size. In the U.S., primarily for drawings, we use B size sheets or C size sheets. C is falling out of favor. I don't remember the exact dimensions, but C size sheets are falling out of favor. Pretty much everybody is defaulting to a B size sheet. B is 11.5 by 17 inches. It's the same height as an 11.5 or 11 by 17. Sorry, not 11.5. 11 by 17 sheet of paper. It's the same height as our standard letter size sheet paper, but it's twice the width. Okay, so that gives us a nice big landscape to be able to draw on these, and they are all drawn in landscape format, not profile format. If you don't know what that is, landscape format is when the long edge is horizontal. Profile is when the long edge is vertical. So we're going to go landscape. So we're going to click on B ANSI Landscape. Sorry, that took me a couple clicks there. B ANSI Landscape is the one that we're clicking on right here. Up above it, you can see that we've got a landscape, a portrait. So again, portrait is, sorry, I kept saying profile. I meant portrait. Portrait mode is when the long edge is vertical. Then we've got C landscape, D landscape, etc. We're going to go with B landscape, and we're going to hit OK. When we do that, it's going to open up our generic SolidWorks template. The majority of you will go into a business that has pre-made templates. If they don't, there are a metric ton of tutorials to show you how to how to create your template from scratch, basically, or how to modify this one. We're not going to go over that in this class. I might go over that next week, just depending on how you guys do with this and kind of where we sit. Again, you know, I'm kind of fudging around and figuring out what we're doing this semester. So we're at this point. Now over on the left-hand side, very similar to when we open up an assembly, it's going to open up this model view. Model view is the insert component kind of for drawings. This is the model view that we're actually going to be inserting into our drawing. Okay, so we're going to click on Extrude EXE1, come over here into our model space, and click. And you haven't selected drawing. Let's try double-clicking. There we go. Double-click on it. Okay, so now if I come over here into my model space, you can see that I've got this this box there. This box is showing me the approximate outline or the approximate space that my model is going to take up. So I'm going to go ahead and click, and that's going to drop my model in my model space here. You can see on the left-hand side, it has now shifted to what that is. And then I've got the option to drop more views. So I'm going to go ahead and drop a top view and a right-hand view. Okay, with those, I'm going to go ahead and exit my my insert view, my model view thing. I can do that a couple of different ways. I can right-click, I can go up here to the green check mark in my model space, or I can go over here to that check mark there. Let's really quick, before we get out of that, let's go ahead and drop, actually, let's go ahead and get out of that. So we can drop an isometric view just by coming up here and clicking, or I'm going to go ahead and hit my green check mark. So now I'm out of that, right? Okay. So if I now want an isometric view, I can click on this view. If I right click, it's going to give me this option right up here, up inside this toolbar. Third to the right, it's going to say projected view. I'm going to click on that. Then I can come up here and I can drop that isometric view. Now, I just hit escape a couple of times to exit that tool. So now you can see I've got 3 views here, 3 main views and an isometric view. These views are all tied to this view here. So these 3 views here are all tied together. The isometric view is not tied to anything. That's just the nature of the isometric view. So let's go ahead and alter the scale of this isometric view because this thing is gigantic. We're going to need a little more space than that for the drawing, the dimensions and stuff. So over here on the left-hand side, we've got an individual tool or an individual option pane that will change for each one of these views that I select. So I'm going to come down here about halfway where it says Scale. I'm going to click Use Custom Scale, click the drop-down, then I'm going to go 1 to 2. So now it's half the size it was before, and I'm just going to kind of shove it up here in this right-hand corner, get it out of my way, give me plenty of space to be able to do the dimensions and stuff on my models down here. So with that, I'm going to go ahead and end this video, go ahead and continue on to the next one to get into the dimensions.